Welcome to qnawire.
Okay, here we have two pulleys connected together. We know that point A on the smaller pulley, the 4-inch pulley, is moving up at a velocity of 3 feet per second, or 36 inches per second. And we want to find the velocities of the center of the pulleys and of point B on the larger pulley. So first we can calculate the velocity of point O here. The velocity of point O will just be due to some of the radii involved here. So this will be the radius of the larger one, so B, divided by the radius of the smaller one plus the radius of the bigger one, times that velocity of A. Which would give us then, that's an 8 over 12 times 36. So that should give us 24 inches per second. So fairly simple. Then we want to calculate the angular velocity of the larger pulley. The angular velocity of the larger pulley will just be the velocity of that center of rotation, or the center of the pulleys, divided by the radius of that larger pulley. So that's 24 inches per second divided by 8. In other words, that's 3 radians per second. So nice and simple so far. Then we want to find the velocity of B about that center of the pulleys, which is pretty straightforward here. That this will just be the radius of that pulley times omega, which is kind of just the opposite of what we did up here. So that'll just be 24 inches per second again. So next, we need to know what direction this is moving in. Well, that's moving to the right. So that will be in the, if that's moving to the right, that's moving in the I-hat direction. We have to think about what direction the J-hat or the O is moving in, which I just gave it away. That's moving up, since we know point A is moving up. So that will be in the J-hat direction. So when we want to find the velocity of B, velocity of B will equal the velocity of O plus the velocity of B about O. Well, that's 24 inches per second in both the I-hat and J-hat directions. So if we want to find the magnitude of this, we can just take the velocity in the B direction dotted with itself, and then take the square root of it. So we would find that the magnitude of VB is just the 24 inches per second times the square root of 2 in this case, which would give us about 33.9 inches per second for a magnitude.